Okay, children, today we're going to be moving on and we're going to be talking about calculating GDP. So I already taught you a little bit about what GDP is and what counts as part of GDP and what doesn't count. Today we're going to be talking about the difference between nominal and GDP, real GDP, and then the GDP deflator, and using those numbers to find percent change in GDP so we can see whether the economy is growing or not, and percent change in the GDP deflator so we can see what price increases are doing, what's happening with inflation, basically. All right, so again, nominal GDP is like a snapshot. It's this year's production in this year's prices. Real GDP is this year's production, but it's adjusted for inflation. Real GDP is better for making a year-to-year comparison. It's just better for that. All right, so if we look here, and I'm going to have to actually smallify this so you can see what I'm doing. Nominal GDP, we're going to get it right now. So this is for if you're doing nominal GDP, you're taking the value of final goods and services evaluated at current year prices. So nominal GDP, to calculate it, you take the units of output for this year times the price per unit for a given year. So let's look. We got bananas and lattes. Those are the only two goods being produced in this economy. For year one, to calculate year one's GDP, we would take our price of bananas. So it cost $1 to buy a banana in year one. We had 5 bananas that were sold in year one. So we made $5 off bananas. So it's going to be hey, I didn't mean to do that. It's going to be $5 plus $6 is what a latte cost in year one. And we sold 5 of them. 5 times 6 is 30. So plus the $30 we made off lattes, and that is going to come out to a nominal GDP of $35 for year one. For year two, we're doing the same thing. $1.50 was what a banana cost in year two. $10 is the quantity of, 10 bananas is what we had. So that's 10 times 150. That's going to be $15. $15 plus whatever we made off lattes, $7 times 7, that is $49. Okay, 49 plus 15 is going to be 59 plus 5, $64. Yoink. So we made $64 in year two nominal GDP, and then finally year three, 12 times 2, it costs $2 for a banana in year three. 12 were sold, so that's $24 plus 7 times 9. What is 7 times 9? $63. Where's my dollar sign? $63. That was foolish. It was $87. I added that 20 twice for some reason. Okay, so now this is what our nominal GDP is for each year. So nominal GDP rose from year to year. It was $35 in year one, $64 in year two, and $87 in year three. Only problem is prices, if you didn't notice, prices changed each year. A latte cost $6 in year one, but by year three, it was $7. Banana cost $1 in year one. By year three, it was $2. And so just this increase in nominal GDP doesn't really tell us the true story or the whole story. It doesn't tell us how much prices changed within those years. I got to add these 35. Yoink. Sorry, got to bring them over here so we don't get mistaken. 35, 64. Yoink. Aye. 64. And then, what was it? 87? Let's make sure I remembered correctly. Yes. Okay. So now there's another way to do this. We need the real GDP. This is what really matters. This is a better way to evaluate changes in GDP, actual production. Remember, the most important letter here, the most important word in GDP is the P, production. Production is what matters. Production is what we care about. And so to better measure what happened to our production, we need to account for that inflation. We need to get rid of the inflation. For the rest of this year, from now on in this class, when we're talking about real anything, we're accounting for inflation and getting rid of the change in prices so we can actually compare between years. So this is going to be, real GDP is going to be the value of final goods and services evaluated at base year prices. So we establish a base year so we can compare output in different years by keeping dollars constant. That messed up there. By keeping dollars constant, this eliminates the impact of rising prices have on GDP. So we can actually compare between the years. So the way you do this real GDP. You take the units of output times the price per unit from the base year. I am going to create a base year right now because I realized that I never did that. We are going to say, oops, best year. This is going to be base year. Year 2 is the base year. Year 2 is going to be our base year. Okay, so that means, oh wait, no, I don't want to do year 2. We're going to do year 1 because a dollar is easier than $1.50 math. Okay, so that means that for the whole year, or sorry, for every year when we're doing GDP, we're pretending that the prices never changed from year 1. We're pretending that base year price of year 1 is our price for everything. So when we do this, we don't even have to do anything for year 1 because we're using year 1 prices. So year 1's real GDP is exactly the same as year 1's nominal GDP for year 2. Now we take our output from year 2, 10 bananas, and we're going to multiply it by the base year price of $1. So that's going to be that's going to come out to $10 plus whatever we get for lattes for year 2. So it's going to be 7 lattes times the $6 that they cost in year 2, and that's going to be $42. And that equals what? $52. Yoink, 52. All right, so 52 is what we have for real GDP for year 2. So if you look here, we definitely had an increase in real GDP. So we had an increase in production from year 1 to year 2. It's just not as big of an increase in production as it looked like if we had just kept it at nominal GDP. And then finally, for year 3, we made 12 bananas that cost $1 each. So that's going to be 12 plus whatever we got for lattes. 9 times 6 is what, 54? Hopefully I'm right. So what's that? $64. Okay, yoink. All right, so again, our real GDP has increased. It has just not increased nearly as much as it appeared that it would. All right. So now we're going to take these numbers and move on to the next part. So our real GDP gives us a more accurate representation of what's happened to our production over those years. So some of this increase in nominal GDP was just a change in prices. It doesn't mean that we actually made more. Now we can calculate what our GDP growth rate actually is. And we do that with this simple equation over here. You're going to have to remember this for the rest of the year. No matter what we're talking about, if we're talking about a percent change, this is our percent change formula. In fact, I am going to call it that. Percent change formula. And it's just like this. You take the new value minus the old value divided by the old value times 100. And what we're going to do here, let's go ahead and see what our percent change or what our growth rate was between year 2 and year 3. From year 2 to year 3, we went from $52 to $64. Our new value is going to be the most recent year. So year 3 will be our new value. So that will be $64 minus our old value, which was $52. That should be money. $52 divided by our old value of $52 times 100. And that equals what? Okay, I'm going to have to give myself a little more space here. Times 100, and I'm going to have to do, why can't I type in there anymore? I'm going to have to do a little bit of math here. All right, so 64 minus 52 is what? $12? 64 minus 52 is 12, divided by 52 is 0.23 blah, 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 times 100. And we had a 23% increase. 23% increase in prices from year 2, or sorry, in real GDP from year 2 to year 3. Now in real life, that's a crazy amount of growth. Like your best bet for growth in GDP from one year to the next, like we hope for like 2.5 to 3%. That would be wonderful. So this is insane, but this would be an expansion. And the reason that it's insane is because I just made up these numbers up here. All right, next. To get our GDP deflator. Okay, the GDP deflator is a type of price index. It's a way that we can index our change in prices in order to measure inflation. It's one way to measure the average price level, aka the rate of inflation. So the base year is always going to be 100. So first and foremost, let me add in here again that we had a base year that we picked. Insert text box. Got a text box over here. Let's get our text box on. I keep saying best year. Base year. Yoink. Hey, no. Yoink. Dude, how much space do you need? Yay. That seemed like more than was necessary, but whatever. All right. So our base year is year one. And so our base year is always going to be 100. You just remember the base year keeps it 100. Yeah. Okay. So our GDP deflator. So to get the GDP deflator, the reason that this is 100, I'll show you real quick. You take your nominal GDP. Right now, our nominal GDP is $35. Divide it by your real GDP. That's $35 for the base year, because in the base year, if that's when the prices, that's the prices that we're using, nominal GDP and real GDP are going to be the exact same thing. So you go nominal divided by real, 35 divided by 35 is 1, times 100 equals 100. All right, next, we take our nominal GDP and to get our GDP deflator for year 2. That looks ugly. For year 2, we take nominal GDP, 64, nominal divided by real, 64 divided by 52 times 100. I apologize, children. Nominal 64 divided by 52 equals times 100, and that's going to come out to a GDP deflator of 123. And then we got to do it for the last one too. 87 divided by 64 times 100. Hey, and that equals what? Okay, so now I got to do it on my calculator. Oops. 87 divided by 64 equals times 100 equals 136. All right, so our GDP deflator in year 1 is 100, year 2 is 123, and year 3 is 136. Okay, now we can take this information over here to our last table and use it to make some sense of stuff. Okay, now we can measure our inflation rate, aka the percent change. Come on, yoink. All right, there you go, got it. All right, now we can measure our inflation rate, aka the percent change in prices from one year to the next. Remember, this is new minus old divided by old times 100. And so our new number is the most recent year, so year 3. New is 136 minus old 123 divided by old 123 times 100, and we're going to have to math that. So 136 minus 123 is what? Is that 13? Let me make sure. 136 minus 123 is 13 divided by 123 is 0.105 times 100. So it comes out to about an 11% change in prices. So inflation from one year to the next, from year 2 to year 3, was 11%. We had an 11% inflation rate.